Imagine a world where the physical and virtual realities are indistinguishable. How might this impact our lives and the industries we know today? This is not a mere figment of science fiction anymore, but a perceptible future that we are steadily moving towards. Virtual reality as we know it is already making strides, immersing us in digital environments that stimulate our senses just like the real world. But what if we could take it a step further? What if we could develop a hyper-realistic virtual reality that doesn't just simulate but replicates the complexities of our physical world? This could revolutionize not just entertainment, offering experiences beyond our wildest imaginations, but also education, creating immersive learning environments. Healthcare could benefit too, with virtual reality enabling complex surgical training or therapy sessions. The key to unlocking this hyper-realistic virtual reality could lie in a complex equation, the McGinty Equation. The McGinty Equation, often seen as P(xt) equals sine skew of txt plus fractal xt dmqs, may seem daunting at first glance, but fear not, for we're about to break it down into digestible chunks. Let's start with the first term, P(xt)xt. This is the solution of the free quantum field theory. Quantum field theory, or QFT, is the theoretical framework describing the quantum mechanics of particles and fields. It's the math behind how particles like electrons and photons interact. Now let's move on to the second term, Pis fractal xtdmqs. This represents the fractal potential. Fractals are patterns that repeat at every scale. They're everywhere in nature, from the branches of a tree to the spirals of a galaxy. In the McGinty equation, this term describes a self-similar fractal structure defined by constant parameters, but the McGinty equation doesn't stop there. It has a modified version, P's xt equals sine P's qft plus P's fractal xt dmqs plus P's gravity xtg. This extra term, P's gravity xtg, represents the perturbative effects of gravity on the quantum field. The letter G here characterizes the strength of the gravitational force. This modified equation combines quantum field theory with general relativity, two of the most fundamental theories of modern physics. It's like having Einstein and Schrödinger working together on the same equation. The fractal correction term can be derived using integral calculus, Laplace transform, and the convolution theorem. These mathematical tools help us understand the intricate patterns and complexities of the universe, from the smallest particles to the largest galaxies. So, you see, the McGinty equation is not just a bunch of symbols, but a key to understanding our universe. It bridges the gap between the quantum and the cosmic, the infinitesimal and the infinite. It's a mathematical testament to the beauty and complexity of the world we live in. Now, you may ask, how does an equation from quantum physics relate to virtual reality? Well, let's dive into that. The McGinty equation, a complex formula from the realm of quantum physics, might just hold the key to the future of virtual reality. Firstly, let's revisit our understanding of the McGinty equation. It's a mathematical representation that brings together the concepts of free quantum field theory and fractal mechanics. It's also been modified to incorporate the perturbative effects of gravity on the quantum field, characterized by a parameter, G. This equation is more than just symbols and numbers, it's a way to understand the fundamental nature of reality. So how does this equation translate into the world of virtual reality? Well, virtual reality seeks to recreate our perception of reality. It's all about creating a hyper-realistic simulation that fully immerses users, tricking our brains into believing we are experiencing a different world. To achieve this level of realism, we need a deep understanding of how reality works at the most fundamental levels, which is where the McGinty equation comes into play. The McGinty equation, with its focus on quantum field theory and fractal mechanics, offers insights into the granular structure of reality. It could potentially guide us in creating virtual worlds that mirror the intricacies of the real world at a quantum level. Imagine a virtual reality that's not just visually and audibly immersive, but also realistically mimics the fundamental behaviors of our universe. Moreover, the equation's inclusion of gravity's effects on the quantum field may help us develop virtual environments where gravity behaves just as it does in our world. This could lead to a whole new level of physical immersion in virtual reality, where your movements and interactions are as realistic as they are in the real world. In essence, the McGinty equation could be the secret ingredient in creating a fully immersive virtual reality. It's a fascinating intersection of quantum physics and technology, and we can't wait to see where it takes us next. We've seen how the McGinty equation and virtual reality intersect, but what does this mean for our future? Let's dive deeper into this fascinating intersection between physics and technology. The McGinty equation, a marvel of modern physics, offers us a comprehensive understanding of quantum field theory, gravity, and fractal structures. By applying this equation, we can create a hyper-realistic virtual reality system, one that fully immerses users in virtual worlds, transforming not only how we play, but also how we learn and work. Imagine, for instance, a physics student exploring the cosmos from the comfort of their living room, or a medical student conducting a complex surgical procedure in a risk-free environment. Or consider architects and engineers, designing and testing structures in a fully immersive, three-dimensional space. The potential applications are as endless as they are exciting, but it doesn't stop there. The McGinty equation's fractal component, described by constant parameters V0, L, and S, allows for the creation of self-similar virtual environments. In layman's terms, this means our virtual worlds can be infinitely complex and endlessly intricate, just like the real world. Moreover, the inclusion of gravity in the equation, represented by the parameter g, allows us to simulate the effect of gravity on these virtual worlds, thereby enhancing the realism and immersion. Imagine feeling the pull of a planet's gravity as you walk its virtual surface. It's an experience that promises to revolutionize how we interact with virtual spaces. In essence, the McGinty equation provides the theoretical foundation needed to create virtual worlds that are as close to reality as possible. By integrating this equation with virtual reality technology, we can revolutionize industries ranging from entertainment and education to healthcare and architecture. It's a powerful combination that promises to redefine our perception of what's possible. In conclusion, the McGinty equation, when combined with virtual reality, has the potential to transform our world in ways we're just beginning to understand. The future of virtual reality, powered by the McGinty equation, promises a world beyond our wildest imaginations.